Hi. Unfortunately, my Ukrainian, even my Russian, are very rusty. I had the same problem 2 weeks ago in Brazil. I guess I speak more Portuguese than Ukrainian, so please bear with me. I see the room quite shortened, so just come to the front. We're doing here an interactive session, so just come a bit to the front. Before we start, JCache is a Java topic, so I guess everybody here is a Java developer? I see a lot of people. Perfect. So, as said, we were in Brazil a couple of days ago, and in Brazil it's common to do some sports activity first. So what we did is, everybody stood up and we did something. Come on. I mean, it's early in the morning, so hey! Perfect! Okay, that works. So, interactive. That doesn't only mean sports activity, it also means we're going to play a game. How do we play a game? I ask a question, and everybody says yes. That is an easy game, isn't it? So, did anybody read that? Perfect. Okay, back to the topic. Now let's get serious here. I'm Chris. I guess Christoph works in Ukraine. It doesn't work in a lot of other countries, especially in the Asian area. Nobody knows how to pronounce Christoph, but they are kind of familiar with Chris, so just call me Chris. The 9+ years Java experience is not exactly true. I just stopped counting it somewhere. It's like 11, maybe 12 years. I don't really know. I worked for a couple of weird companies. Ubisoft. Do we have some gamers here? Maybe. So Ubisoft writing low latency game servers. I worked for HRS, which is like the Expedia thing in Germany, doing low latency stuff for travel management. So in general, I'll do all this weird stuff that most of the Java developers don't want to do. I know that, for example, in the Russian area, there are a lot of hardcore Java developers. I think Ukraine might be the same. A lot of people doing performance optimization, or maybe things like network protocols, GC optimization, all those weird stuff. If not, well, you can give me some money and I'll come over. I like Ukraine. I'm here for the first time, so I would love to come back. Okay, if you're interested in a kind of reasonably often updated blog, that is one of the addresses that is possible. We see a couple of more later on. Okay, so the topic is JCache. Does anybody know about JCache yet? Perfect. At least one. Two people. So, but you know about caching, right? Everybody knows about caching. Everybody used to cache somewhere, I guess. Or do you write those small applications that don't need caches at all? I don't think so. So what is caching? By the way, the picture with the cat, you know every slide deck needs a cat, right? So why do we cache? Well, going to the typical caching example, I guess squirrels are one of the best caches in the world, and it's a natural cache. They collect and store in the autumn. They collect all the nuts and they hide it somewhere. If you know Ice Age, that is not exactly a squirrel, but it's very close. And they save it because they need to access it when it's a hard time, when there's a need for it, and they want to access it fast. They don't want to starve, right? So with caches, it's the same thing. We want to warm up our caches. We want to store the data in memory whenever we have time, because our database is horribly slow normally. And we want to access it whenever we have a peak in the system. So what we actually want is fast delivery. We don't want our customers, our users on the website, our own people using our client technology to wait just because we have an Oracle database or something underneath that is not going to work. So that essentially means we need to store data in memory. In memory, we have like 100 nanoseconds. It's obviously not as fast as L1, L2 cache, but I don't think that anybody has a CPU here with a terabyte of L1 cache. If so, please give it to me. That would be cool. But yeah, so 100 nanoseconds for RAM access, for normal main memory. It's actually still quite fast to access network data. So for a gigabit network, it's about 0.01 milliseconds. But if you look, even the fastest SSD is still way slower. It's 15 times slower. And that is only a gigabit network. So our current test lab in JCache, I'm obviously working for JCache, we have 1, 10, and 40. 40 gigabit is really nice. You're coming down to 23 microseconds network round trips. That is amazing. If you really want a cool network at home, buy solar flare cards. They're not as expensive as you might think, but they're still quite expensive. So the other thing for in-memory caching, well, we have two graphs here. We have the price per megabyte, which started for a single megabyte at $6,480 in 1980. And we're down to less than a cent, a half cent about. We're even further down by now. But in 1980, there was like 625 kilobyte. Who remembers the 640 kilobyte area? Come on, hands up. You're not as old. Perfect. So who said that? There was some guy, we never need more than 640 kilobytes, something like that? Well, he was quite close. So in 2013, we were at 16 gigs. My computer at home now has 32. I think 1632 is like the general desktop computer, right? You're not agreeing? Well, we're working on the interactive thing. So and that is desktop computer. That is a pure desktop computer. 16 gigs is not as much anymore. If you go to servers, 512 megs, a terabyte of RAM is not unaffordable anymore. It's really easy to get a terabyte of physical RAM inside of a single machine. That is nice. I mean, SSDs and a terabyte SSD, it's pretty much the same price, and you're slower. So don't do that, as long as you don't want to store data, really. So I think Big Bang Theory works here as well, right? Everybody knows fun with caches. What is the real term? Fun with flags. Come on. We're doing it interactively here. So, fun with caches. Everybody knows that caches are simple. You all said you used cache in the past. So, who wrote his own cache in the past? Still 6 people. 6 people. Does anybody disagree that caches are simple? No, it doesn't look like. Perfect. So, the first and easiest solution is roll your own cache. And that thing is, by the way, called a ham docker. You can buy this in the US. It's a mixture of a hamburger and a hot dog. Don't ask me why. So, caches are simple. We have a concurrent hash map, and we have 2 methods, put, get. If you want to make it very obvious to your colleagues, you call it cache and retrieve. It's easy. The problem is, well, you never remove data. That's probably not what you expect. So how does a cache work? Well, you put something into the cache, and you normally say, hey, please keep that in the cache for a minute, for 10 minutes, for an hour, for 24 hours. So these are like the normal values. So what we need is something with TTL. TTL, time to live, you set up 24 hours, you put it in the cache, and it is automatically removed after 24 hours. This code is not meant to be readable anymore, so don't try hard to read it. So I'll just quickly go through it. We store the creation timestamp, which is just the milliseconds, whatever. And we have like a TTL setup. TTL could be, as I said, 24 hours. And this code only has one problem. It works perfectly fine as long as we access the same keys. But for example, imagine a news site. Articles are nice for 24, maybe 48 hours, but probably nobody will access them afterwards anymore. That means even here, our cache is growing because we only remove data when we access the key. We figure out the key is removed, or the keys expire and we remove it. OK, so operations probably don't like that. We don't have any DevOps guy or operations guy here? Oh, we do. Perfect. So you probably can explain how hypervisors are configured and what overcommitment means. So people know how operations normally creates or configures virtual machines on hypervisor? No? Okay. So by default, imagine you have a 64 gigabyte server, physical server, 64 gigabyte physical RAM. And operations knows, well, it's a Java application, and we don't have too much users, so none of the systems will ever use those 64 gigs. So you create 10 virtual machines, and you give everybody 32. So in theory, if everybody uses every virtual machine uses all the RAM, you would end up with 320 gigs of RAM, which is not available. Do you disagree? No, it's yeah, I know. We had this problem at Ubisoft. We had to explain them, don't do that, because we know our memory limits and we want to exactly that memory. So it was hard. We had to explain operations, don't do overcommitment. We know what we're doing. But normally, what happens if you use such a cache, operations will tell you, hey, this is not what we want. Your memory is constantly growing. Something is very wrong here. Well, as Java developers, everybody would come up with a very, very simple solution. Let's add some auto cleanup. Let's have a thread in the background running and looking for the values, and whenever something's expired, just kick it. Operations is happy. Our application might not be happy anymore. So there are two problems in Java that are very, very common. So that is the first one. As I said, we're going to do this interactively, so we're going for another game. What is wrong with that code? I give you a slight hint. It's an iterator. It is thread safe. That's not a problem. It's a concurrent hash map. Sorry? No, we're using iterator remove. That's also not the exact problem. So that everything is fine here in this case. No idea? So imagine you call this with 5 million elements instead of 50. What happens? The runtime goes up. That's a linear growing runtime. And in itself, that is not a problem. But what normally happens, does anybody still use threads? No, we're using executor services. So in an executor service, what you do is, well, you either create a forever running loop, and you hopefully do some thread sleep somewhere to not block a whole core, or you use a schedule executor service. And I guess everybody knows schedule executor service? Yes, perfect. Do you know the difference between schedule at fixed rate and schedule with fixed delay? So schedule with fixed delay will wait until this is ready, adds the delay on top of it, and will reschedule the task. What people normally use is at fixed rate. And this is not a very uncommon mistake. We had the same thing in our code base. And this is also not made-up code. This was in JCache. And I hope that up to this point we fixed it. Nobody really used expiration in JCache. Otherwise, it would be quite embarrassing. So why do we go for distributed computing? Well, or for caching in general, not distributed computing, distributed caching or caching in general. We want to scale out our applications. Distributed caching is very easy to scale out. As I said, you have cluster, and you add more and more nodes if you need to cache more. But you can also add more clients, more front-end servers, accessing the same data. And you can scale it independently. So you don't want to scale up anymore. That is the main term. There were some version of the slides where it had a slightly Oracle logo somewhere on his chest. Oracle always has or not only Oracle, even SAP and IBM, they probably can always sell you something bigger. It just costs triple of the money you paid last time, and you get a faster machine, which is maybe 1.5 times as fast. That probably works for the next few years, but eventually it will drop down. So you definitely have to scale out somewhere. And scaling out is what all the NoSQL solutions do. Not only key value stores like a map or a cache or something, but also graph databases, the document stores. Everybody's going to scale out because they figured out scale up just doesn't work anymore. Moore's law has like a huge drop somewhere. OK. As I said, distributed partitioning also means we need to partition data to make it useful. Because if we replicate data to every node, we can use local caches. Local caches have the problem if you have 10 nodes, eventually everybody will cache exactly the same data because that is your local or your current data set. So if we replicate data to every node, well, we have exactly the same use case. We have a lot of nodes storing the exact same data. That is not what we want. We want data partitioning. Partitioning means you have 10 nodes, and you have 1 million items, and in a perfect world, every node will keep exactly 1 million items. That's not 100% true because you have to do some math calculation, but in general, the more items you put in, the more it gets kind of equalized, at least on percentage level. Maybe not on real number counting. But the other thing is, if you do data partitioning, you want to make it handy to be used. We see all these little sticks here. It's easy to handle. You don't have to wash your fingers afterwards. Even if you ate cake, you don't need a fork to do that. It's very convenient. And for data distribution, it means you don't want to show the user how data distribution works. You need to make it transparent. You need to kind of hide it from the user because you don't want the user to use a different API than for local caching. At least I agree with that point. I don't think that anybody doesn't. So that is where we come to the point of the talk itself. And the talk is about JCache. We had 2 people already knowing about JCache. I actually like the name of the project, or the name of the specification, the nickname. JCache means Java caching. And it is the new caching standard from the Java community, from the JCP, from the Java community process, to create a common cache interface for all these Java caches. It is JSR 107. If somebody wants to read the specification, as I said, it's 172 pages, I guess. You most probably don't want to. JCache has a very nice documentation. I wrote it. It's just 30 pages. It gives you the best introduction. None of the other vendors put that much effort in its documentation itself because all of them just referring to the specification that nobody wants to read. I think that is not the right way, but well. So the specification, and I guess everybody knows how a specification works, it has a lot of things that are meant for vendors. Like, how are certain things behave? How do they have to be implemented to pass the TCK? This is not what the user is interested in. So we want JCache because we don't want a cache, because we don't want a caching standard. No, because we want a caching standard. We want to be able to exchange our vendor, our caching vendor, whenever we need. For example, we have a very small application in the beginning, or we have a unit test, and we want to test our solution, but we don't want to start up a JCache cluster, an InfiniSpan cluster, or whatever. We want to test it locally. That means you use JCache and put it under your JCache provider, and it works because it's a cache. It conforms to the JCache specification, so everything is happy. And then you deploy it, and well, in the beginning, you're a small startup. You might have just 2 nodes. JCache is still fine. Just do a replication on JCache, and everybody is happy again. But then you find this critical mass, and you grow out. Oops, you grow out, and there are not only 1,000 customers anymore. There are 1 million customers, and you figure out, shit, I can't do that anymore. Replication doesn't work for me. So you just take another JCache vendor, you put it underneath the application, and you're happy again, hopefully. In a perfect world, that is at least what should happen. The reason is, as I said, we don't want to care for proprietary applications. Does anybody know who it is? He was recently fired, together with all the other 2 guys. That is the guy from, what is the name? Right, Top Gear, right. I was just missing the name, Top Gear. It wasn't his fault, at least. But he was so nice to say, hey, if you guys go, I'll go as well. So yeah, we don't want to have proprietary caches. We want to stay vendor independent. I thought it was a different picture, but okay, it works. So as I said, vendor independent. Why is it in quotes? Well, does anybody use JPA? Yeah, Does anybody use many-to-many relationships, which are not part of the specification, or at least one, two? So what happens if you use many-to-many? You go out of the specification and you bound yourself to a vendor. That is not what you expect from using a standard specification, especially not if you're at version 2.1, 2.2, whatever the current JPA specification is. I think it's 2.1. So they had a lot of time and they figured out everything. But many-to-many relationships seems to be a mystery. I don't know why. So that is, I guess everybody knows that problem from the past, right? I have like 100 rechargers at home. Every damn mobile phone had a different charger, a different connector. And like, okay, can I put them together? Let's just drill it and it should work. Well, the most expensive one is actually not on here. If you ever bought a couple of mobile phones from Apple, you have like a couple of more plugs. But these are the more common things. So the problem is exactly the same as in most of the Java environments, and that is why you want to look for caching. All of them try to fulfill the same requirements. But everybody has like his own plug. Everybody has a different API. JCache, you see that we share a lot with the Java Collections API. So JCache takes most of the Java collections and Java concurrency stuff, and we try to re-implement it in a distributed environment. Most of the time, transparent to the user. Terracotta and JCache are the same API. Terracotta had something different in the past, so if anybody ever used Terracotta DSOs, you're kind of screwed because they're not developed anymore, and support is running out like next year, I guess. They bought Terracotta JCache a couple of years ago. They re-implemented their API on top of JCache. So, well, same vendor, two different APIs. Oracle, at least with coherence, stayed the same. They just bought Tango Sol somewhere in the past, and the packages are even called com Tango Sol because they try to be as backward compatible as possible. So they even had the nerve to call it com Oracle by now. InfiniSpan has its completely own API. They also call it cache, but it doesn't look like anything else. Yeah, as I said, JCache. Well, you have your custom thingy, which I said in the best case you call it cache and put, cache and retrieve, or cache, retrieve, and expire, whatever. But it looks pretty much, I guess, it will look completely different from everything else. So that is like the very basics thing, because you don't have this 170 requirement pages. And then you have JCache. I guess micro USB, well, now it's USB 3C, I guess, thanks to Apple. The other one has still the old one. But it seems like everybody is now going to these micro USB and USB 3 thingies. So at least we just have two versions. I guess everybody in the end will move to USB 3. So you have like a common plug for everything. At least let's expect that to happen. So for JCache, as I said, we have a couple of vendors. We have a specification, and the specification is still quite young. It was finished in 2014, end of 2014, after it was started in 2001. Did we had some gamers here? Does anybody know Duke Nukem Forever? It also had like 13 years of development time, so JCache can do the same thing. What actually happened is they started in 2001 because some guys, three guys, I don't remember the names, figured out, hey, it would be cool to have like a common cache interface. And they worked on it for about a year, and then it seems like, oh no, nobody needs a cache interface anymore, so let's abandon it. So it lay around for 10 years or something, until in 2012, two people picked it up. Actually, the creator of JCache, which is now our CEO, so we got him from Terracotta, and someone from Oracle Coherence team, they said, okay, let's create something common. There's no use to have all these different things. Caches are still kind of simple, so we don't need that. We don't need to have 100,000 different interfaces. And they wanted to create a new JSR, but they figured out, oh, there is this 107 JSR thingy lying around for 100 years, as it feels. And to show how old JSR 107 is, we are currently at 364 or 367. And the number is only increasing, so you can guess how many JSRs were in the meantime. So they started it over again, and in 2014, they said, OK, now let's get out the first version, because we want people to use it. It's not exactly final yet. There are a couple of things missing. I'll come back to that in the end. But in general, we're quite close, and let's put it out. It is 13 years. We don't want to be worse than Duke Nukem Forever, so we need to get it. So there are a couple of JCache implementations. As I said, I'm working for JCache, so obviously the first choice for everybody here is JCache. EHCache, all of them are TCK compliant. That means they passed the JCache TCK and proved that the specification is implemented as it was meant to be. So EHCache InfiniSpan, Apache Ignite, if somebody knows GridGain. I know you guys normally don't like Russian people, but GridGain is fairly OK, even if it is from Russia. You have Oracle Coherence. I think I'm missing Apache Geode, which was Pivotal Gemfire, which was SpringSource Gemfire, which was VMware's Gemfire. I don't know how many companies were in the past. I'm not sure if they already passed the TCK, but they're quite close at least. And you have a lot of other implementations that claim to support JCache, but they never passed the TCK. So officially, they can't claim it. And that is, well, I said in the beginning, NoSQL databases. So MongoDB, Java client has JCache support, Couchbase, Cassandra, all those databases that are not meant for caching. And it's probably good that they don't pass the TCK, because you don't want to use the database for caching. Otherwise, you can stay with the Oracle database or DB2 or whatever. So I hope that feels like a success. At least it feels to me like that. I was happy when we got this micro USB thingy. I was like, wow, 3 different devices and all have the same recharger. That's so cool. And it kind of feels like the same way. And as I said, we're not yet there. I'm part of the expert group as well, or was part of the expert group before JCache 1. And we're missing a couple of things. For me, the most important thing is asynchronous operations. I mean, if we look at the current trends in development, everybody is going to this reactive, event-driven architectures. That means you definitely have to have support for asynchronous operations. Every provider currently has something like that, but most of the guys, including us, use futures. Futures have some weird contracts, like, OK, you do a put operation in a distributed environment, and you return a future, and someone calls cancel on the future. Do I have to roll back, or do I just cancel wherever I am? Well, a future is maybe not what we want in this case. We more want a promise which says, OK, I've done that, but don't give me any option to cancel the operation here. So yeah, we might need a better abstraction for asynchronous operations. And there are some proposals. There's this reactive stream, I guess reactive stream API, whatever it's called exactly. It's a different project. It's not yet a JSR, but it looks like we probably get into the JCP as an official standard. It creates promises and kind of things. So futures are not always the right thing to do. The other thing, well, until yesterday, until Wednesday, I didn't really agree with it. People wanted transactions in caches. I wasn't aware why you won't have a transactional cache, because it sounds like very weird. But somebody gave me a real use case, so, well, shit. Up to that point, I made it easy, and I would have voted no. Now I would vote for yes. So, for example, one reason why you want to have transaction support in your cache is you have an underlying database, and you want to make sure that it is written to the database. Yes, I kind of agree with that. So you are in a JE application, and your system is working, and you're pushing something to the cache, and you want to make sure that it is written to the database. Yeah, well, you might want to be part of the JE transaction. I kind of agree. Well, these are the biggest two. I forgot about the third one. There are 3 big topics. I don't know what the third one is. It doesn't seem to be important to me. So let's go to demo time. Unfortunately, it don't look like that yet. So it seems like it kind of works with the pictures. So We're out of pictures. I couldn't find any pictures for source code, so we fortunately have to go to source code. So that is like a very quick introduction into JCache, into the JCache API. And if anybody ever worked with Java specifications that are meant to be implemented by multiple vendors, you have this Java service provider SPI, which is hidden in service loader. It's a class from Java. And you give it a class name or interface name, and it tries to figure out all the implementations that are lying around in your class path, or in Java 9 in your module, what do they call it? Module path? Module collection? I don't know. So in Java 9, we get this Java module thingies. Just think of it as a class path. It pretty much is the same thing. So you ask the caching class for, please figure out all the JCache providers available in our class path. In the best case, and that is here, you just have one. And in the very, very perfect world, it is JCache, obviously. But for JCache, it is InfiniSpan, for example. So if you run your JBoss server, you have InfiniSpan, and InfiniSpan provides JCache support, so you get the JCache provider. So caching provider is like our entry point if we have a standalone application. All this is just necessary if you have a standalone application you want to use JCache. Or if you implement another Tomcat provider like Tommy, or based on Tomcat or something, and you want to implement that for yourself. But I expect that a lot of people these days run their own applications. Maybe Spring supported. If you use Spring, they hide all that, what is upcoming from you. But if you use things like very common applications, this public static void main, I guess they were called in the past, something like that. These entry points into Java programs that normally no Java developer remembers anymore, you have to do those kind of things. So if you don't have a single JCache provider, you have a couple of ways to select one. The easiest way is you load JCache into a different class loader, and you just pass in the class loader and say, hey, here it is, and grab whatever you find. Well, in the worst case, you have to give it a canonical class name and say, com JCache caching provider. Yeah, that's how you select one. Just make sure you have one in your class path and everything is happy. So we have a caching provider selected somehow. Now we get a cache manager. Cache manager in a single application kind of seems weird, because a cache manager adds a scope to your application, or to the application cache. Why do we want to have a scope? The thing is, imagine you're implementing JCache into Tomcat, and I need some water. You're implementing JCache into your Tomcat, and you have multiple deployment applications, or multiple deployment units, or you're writing a framework. There are still companies writing their own frameworks, like OSGI or something. Well, fair enough if you have a use case for that. But then you have a problem. You may want to have different scopes. Imagine you have two teams, and both writing something for your website, and both calling their cache articles. Maybe they're not storing the same exact thing, and they would overriding keys, and you would end up in a different section of your web page, having something from over there. So you need a scope. So every deployment unit would have its own cache manager, and you give it a name. In this case, it is default. The cache manager name is null. That is in a single application. But for example, if you have multiple deployment units, you give it a class loader again if you're having a web app class loader or framework class loader or whatever. Deployment class loader, in OSGI, it's bundle class loader. There are so many names for the same thing. And you give it a URI. URI normally is like the URI address of the deployment unit. File, colon, dash, dash, slash, slash, whatever. It is kind of a weird thing, and the problem here is that works perfectly fine for local caches, but I don't know how you distribute your class loader thingy, so just set it to null. Whenever you expect that you need to scale out your application somewhere in the future, so in 100% of the cases, don't use the class loader as a scope. Just give it a URI and make sure that the deployment unit is always deployed to the same location, or that it is the name of the deployment unit, or whatever. OK, so we somehow get our class cache manager, whatever way we choose. And we have to create a configuration. JCache is configured on premise whenever you need it. And it actually has a couple of nice features. And that is what I like about the JCache specification. I hope at some point we get this for real Java maps. So we create a configuration of integer string. And it could finish here. So we don't need this set types. But these set types give us a nice feature. It adds runtime type checking to JCache. So whenever you put something into the cache, it will make sure it is part of the cache. It is meant to be in the cache. I had this problem once in my past where somebody used my map and casted it to a raw type, putting in something totally different. And if I wouldn't know who it was, I would still kick his ass. And then we come to the more weirdy part of the specification. Unfortunately, you can't do it differently. You create the cache, you get back the cache. So far it looks good. Oh, by the way, you give it a name. So whenever you refer to the same cache, you refer to the same name. Problem with create cache, if we look into the SPI, it will throw a cache exception whenever the cache was created by someone else, which might be manageable in a single application, might be hard in a cluster where you just randomly start up nodes. So, well, if the cache is created, you do get cache. And you put in the name again, and if you activated runtime type checking, you have integer and string again, otherwise just the cache name. OK, so let's combine that together. We try to get cache first. Nobody created the cache yet, so let's try to create it. But since we're in a distributed environment, we might end up getting the cache exception because someone else just created it. We catch it, and we get cache again. And not the fairly nice way, maybe. I think everybody disagrees that this is code you want to write. So the specification figured that out and said, well, any kind of JCache provider is able to create some easy way for you or some transparent way for you to create a cache underneath. Every JCache provider supports that. Not every is configured the same way, but most of the time it looks like something like XML configuration, programmatic prepared configuration. For Hazelcast, you have the Hazelcast XML file. You give the cache a name. You configure the key and value types. Oh, value type. value type. And then you just call get cache. You use the name from the configuration. And Hazelcast or any kind of other vendor will make sure that your cache is somehow created if it doesn't yet exist. So that is code that looks like I want to write, and not this other try-catch multiple time thingy. So as I said, I'm from Germany, and I guess everybody knows who that is, at least after the recent pictures with our refugees we're just taking. She was so nice, shaking all the hands, hopefully everyone's personally, like 50,000 refugees, please shake everyone's hand. And don't talk. Just shake hands for forever if you want to. And that's probably the best picture ever taken of her. And well, yeah, I hope that was easy. So we have 8 minutes 40 left. So let's go to the quick Hazelcast introduction, the shameless plug. And you can just stop listening. It is just 4 pages. As I said, Hazelcast shares a lot with Java. So we implement the Java Collection API, the Java Concurrency API. In most of the cases, we do it absolutely transparent, so you can, we have to move data around somehow, so it needs to be serializable. However you do it, Java serialization, externalizable, some Java serialization, or protobuf, whatever you want to. There are interfaces to implement the serialization to whatever you want to. Since we're using the standard APIs, we're a drop-in replacement for Java, so whenever you have a legacy application and you want to scale out, use Hazelcast, plug it in, exchange your current local hash maps or concurrent hash map with Hazelcast, and you're fine. Disruptively simple. Spring developers? One. So you know Rod Johnson? The creator of Spring. Yes, you do. I knew that. So Rod Johnson is the guy that created Spring, and Spring is a very nice example of how a demo code for a book you write ends up being a product from a company. It's actually quite interesting. He just implemented Spring as an example of his idea, JE done right. So he wrote a book, I think it was JE done right was the title, and Spring was just like, hey, that is how it should be. Well, we see he probably was right. A lot of people use Spring these days still. So he's one of our investors and board members, and he said JCache is so disruptively simple that it sometimes even makes people forget you're using a distributed environment. So time to be happy, because we are Apache licensed, JCache is Apache licensed, so you stay in open source. I think that is the most important thing. You can also use InfiniSpan, which is Apache licensed. You don't use Oracle Coherence because you can't buy without a database or any kind of other Oracle product. So if you have a lot of money, give it to Oracle. If you have just a bit of money, you can also give it to us, but you don't have to. So that's the reason why I say hazelcast.org. As I said, if you have a bit of money, go to hazelcast.com, just spend it on us. Otherwise, take the open source version, download it, give it a try. It's a couple of lines of code in Maven. It's just a single line in Gradle. And what is out there still, SBT and whatever other build system you use. Normally, we're in the Maven repository. Just take the artifacts, and you're good to go. And with that, I say you can do it. Well, this picture, by the way, was not really good in Brazil. It gave me a kind of weird look, but I still like it. So whatever. So 5 minutes 45 left. I think that is exactly what we planned, right?
Absolutely. All right, thank you, Chris. And do we have any questions?
Come on, we said interactive.
Oh, come on. Well, actually, then I have a question. So
OK.
I'm an engineer in IT, so I'm not just the guy who talks on this stage. So question is, did you perform any measurements, any performance tests to compare the
different vendors
with different vendors? Exactly.
Yes, JCache does it internally. So the problem is, I don't believe in benchmarks at all. So
okay.
Apache Ignite or GridGain provided a lot of benchmarks where they prove they are faster than us. Unfortunately, their test is just crappy. We just today, and I don't know why we did that, we released a benchmark on our web page. You can download it. As I said, I don't believe in benchmarks, not even our own. That's why I keep them normally straight internally. But you can look it up. We did a lot of stuff in the past, so there was really a point where they were faster, but it was way back. But the JCache committee or the expert group doesn't do any performance checks. We just do the TCK test to make sure that the vendor really passes the TCK and not just claims it. That's pretty much it. But yeah, well, most of the time I would say do a prototype implementation and do your own benchmarking.
Do you have any case studies which say like, OK, this was before, after we switched to JCache, things become way much better?
So I have one company I can't talk about, but they produce some nice laptops. They used a big company with O in the past for the web page, not for the iTunes store, for the web page where you buy iPhones and stuff. Oh, the phones and stuff, and these smartwatches.
Okay.
And they had the problem that they had a huge latency problem with the caches. They couldn't update it fast enough, so whenever something was on the first day, they sold like a lot more than they actually had because it took so long to update the cache. They recently switched to JCache and the JCache implementation of JCache, and they managed to get down their latency problem by 10% at least. 10% if you sell 200,000 too much, it's still a good number.
It's still the one.
So they sell at least 20,000 less.
OK, very good. Right, anybody else has any questions, any ideas to share with Chris?
Just one last slide. If you want to get a free T-shirt, go to the URL and just grab one. It's actually not that one anymore. We have a new one.
OK. All right. Since Chris is from Germany, we say him vielen Dank. Das war ein interessantes Thema.
So what is thank you in Ukrainian?
Дякую.
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 I stay with Brazilian. That was obrigado.